Yeah, a couple of things in this section that I want to look at to make sure everyone remembers or understands what to do with them. Let's take for the first one, solving for a variable. This one is something that can have a twist in it. And that twist is, I'm going to say solve for y. Problem is, there are two y's in it, a y there and a y there. So what we have to do is figure out with what method will we get a single y by itself, because our goal is to get y equals everything else on one side and the y's on the other. So what we're looking at, we want to isolate these y's first, in a way, sort of. And what I'm going to do, I'm going to first get rid of the z. Let's multiply both sides by z. If I do that, I get 3xz equals 4xy minus 2y. This is where your sense of factoring can come into play, because we have a y in this term and a y in this term. So what I can do now is take a y out of both terms, 4x minus 2. And over here, I still have that 3xz. Well, I had two y's, but because of factoring techniques, I'm now able to have one y because it was a common factor for two terms. And that now allows me, this is like y times, say, 7. I can now divide both sides by 7, or in this case, I'll divide both sides by 4x minus 2. Those will cancel out. And over here by 4x minus 2. And so for the answer, let's bring this up here, and I like the y on the right side, whatever it is I'm solving, the left side rather. So I'll do y equals, and this is what it equals to here. So it's 3xz over 4x minus 2. And with that, I have solved for y. The fact that the other stuff over there is a mess doesn't matter. It's simplified as much as it can, and until somebody tells me what x and z are, I can't give you a number for it. But I don't need to. In algebra, that's not the point of this. It is calculating what it would be up to the point before you are given numbers for the variables. That makes it a generalized kind of statement that you can use in multiple ways rather than just one. Now let's take a look at an absolute value equation, and I need to remind you about this, that when you are solving an absolute value equation, you have two cases. So we're going to do an A and a B case, but first you have to clean it up. In other words, the absolute value part must be by itself with nothing else on the outsides of it. And we have things on the outsides of it. We have a subtract 5 and we have a times 3. So our first job is to get rid of those by going, when you get rid of, you're doing the opposite of order operations. So we're going to add 5 to both sides. 3x plus 1. 7 and 5 is 12. Now we'll divide both sides by 3. And I have absolute value of x plus 1 equals 4. Now we can do case A, which is without the absolute value and is keeping it just as it was, x plus 1 equals 4. And then we can do case B. There are two ways to do it. You can either make the x plus 1 overall subtracting, so it'd be minus x minus 1, or you can make the B side, the left side, the right side, a negative. That to me is easier, so I'm going to do the x plus 1 equals negative 4. Now you solve these for both ones, and you subtract 1 here, and we get x is equal to 3. We subtract 1 here, and we get x is equal to negative 5. So our solution set, x is equal to negative 5 and 3. And you can verify this by going back over here and thinking, if I put a negative 5 in here, negative 5 plus 1 is negative 4, but the absolute value makes it a positive 4, times 3 is 12. take away 5, that's 7. If I put 3 in here, 3 plus 1 is 4, 4 times 3 is 12, minus 5, I still get 7. So both of those are correct. And very seldom, once in a while, you get an extraneous answer where one of them makes it an incorrect statement and you'd only have one answer. But the huge majority of the time, you have 2 answers in this case. But that's why you always check to see if it's 1 or 2. Check both of them. Now, let's solve with rational expressions. And solve means there's an equal sign, and at our end, we want to say x is equal to. So we need to know what numbers will work for this. We already know 2 things. We know that x cannot be negative 2. So x cannot be a negative 2 because that would make a 0 in this denominator here. We also know that x cannot be a positive 2 because that would make it 0 in this denominator. And both of those are true. Oops, 2 there. So we know those cannot be answers. And here in this one, positive 2 and negative 2 both would give you the 0. So we know we can't use it there. Other than that, now we just try to solve it. So you know that you are able to make same denominators, but this is where it's even easier. Multiplied by the lowest common denominator, lowest common multiple, and you will basically then get rid of all of these. So if I have x plus 2 and x minus 2 here, and I multiply all of these by that, I'm going to get rid of all the denominators. That makes this much, 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 much easier. So I'm putting these up here as my multipliers. And here in this case, since this is gone already, the x plus 2's, the x minus 2's cancel out. I have an 8 over here. Here, the x minus 2 cancels with that. So, and the x plus 2 cancels with that. So I have a 5, x minus 2, plus a 3, x plus 2. This is a whole lot easier to work with. 5x minus 10 plus 3x plus 6 equals 8. So negative 10 plus 6 is a negative 4. And add that to the 8 and we get a 12. And we get 8x equals 12. And I divide by the 8, and x is equal to 12 over 8. But of course, we can't leave it that way. It's 3 over 2. So we have as our answer 3 over 2 or 1.5. Decimals are fine as long as you're not having to round them. So you don't want to go more than a couple of decimal places, and then you know you can't use them or can. So if I were to put 1.5 into each of these x's and multiply it out, I would get that this side here is equal to this side here. So my solution set, x is equal to, I don't care which way you call it, 1.5 or 3 over 2. In this case, I'll use the 1.5. If it had been 2 over 3, I do not want 0.67 or 0.67 because they're not equal to each other. As soon as you round it, it's not equal. You could say 2 over 3 is approximately 0.67, but you do not have permission to do that for a solution problem here, unless you check with me about it. But I want an exact answer on it. Whenever I say exact answer, that would mean, of course, that you can't do any rounding. All right. And you can't use an equal sign if you're actually making the approximation. You'd have to use that. Okay, that should help with a reminder about what to do with rational expressions, the absolute value, solving for the variable. And thank you for listening.